Hi everyone! In this video, I will talk about the work of Gaida et al. About ambroxol, a NaV1.8 preferring sodium channel blocker that effectively suppresses pain symptoms in animal models of chronic neuropathic and inflammatory pain. Some of you might have heard of ambroxol. It is a sodium channel blocker and a mucolytic compound used to treat mild respiratory diseases that was introduced to the market in 1976. Its structure consists of an aromatic system linked to a hydrophilic group. It has been proven to block NaV1.8 channels with great potency and also possesses local anesthetic properties. This compound is well tolerated and safe with a good bioavailability. NaV1.8 channel blockers have been considered to be great candidates for the treatment of severe pain states, like neuropathic pain. Since ambroxol suppresses NaV1.8 more effectively than other sodium channel types, it has been chosen as a prototypic compound. Gabapentin is a GABA analog. It has anticonvulsant and analgesic activities, and it is widely used for the treatment of neuropathic pain. Therefore, in this study, the effects of ambroxol were compared to those of gabapentin. This research aims to answer if ambroxol has similar effects to those of gabapentin in the treatment of neuropathic pain. The methods for this paper begin with drug administration. Ambroxol and gabapentin were administered orally. Behavior tests were then performed between 60 and 90 minutes and 120 minutes. Acute analgesia was assessed through tail flick and hot plate tests. The tail flick test response consists of an infrared beam focused on the tail of the rat, and the latency of the tail flick was recorded during 20 seconds. For the hot plate test, rats were placed on a metal plate at 53 degrees Celsius, and hind paw licking and lifting behaviors were registered as nose-offensive responses. Paw inflammation to test mechanical allodynia was induced by injecting complete Freud's adjuvant into the left hind paws of the rats, which after 5 days developed stable symptoms of inflammatory pain. Partial nerve ligation and chronic constriction injury were used as models of neuropathic pain to develop mechanical and cold allodynia, and thermal and mechanical hyperalgesia. The partial ligation consists of tightly ligating the sciatic nerve of the left hind leg and performing a sham operation on the right leg. The chronic constriction injury consists of 4 loose ligatures around the sciatic nerve of the left hind leg. The Hargreaves method was used to measure thermal hyperalgesia by applying an infrared heat source on the plantar region of the rats and measuring the paw withdrawal latency. To assess cold allodynia, a drop of acetone was placed on the plantar region of the animal's hind paws, and the duration of the reaction was measured. Mechanical hyperalgesia was tested with the plantar pinch method on sham and nerve-ligated animals. The skin within the plantar region of the hind paws was gently pinched, introducing short but measurable reactions. An automated von Frey apparatus was used to evaluate pain behavior. A blunt straight plastic filament was placed on the plantar region of the animal's feet, and the pressure was slowly increased. The paw withdrawal threshold was recorded and stored by the device. The formalin paw test consisted on the administration of formalin into the plantar region of the right hind paw and measuring the number of flinches, the first 10 minutes corresponding to the acute phase and from 15 to 60 minutes to the late phase. The plasma levels of ambroxol were quantified using high-performance liquid chromatography, and the analytes and internal standard were detected by electrospray ionization tandem mass spectrometry. Let's move on to the research findings. Figure 1 shows the dose requirement to obtain meaningful plasma levels in humans. Panel A displays the chemical structure of ambroxol. Panel B shows the maximum concentration values of plasma from clinical trials and their relationship with the dosage for humans and rats. It is important to note that rats required higher doses. Therefore, researchers decided to administer up to 1,000 mg/kg per kg to test the analgesic properties of ambroxol. Before moving on to figure 2, I would like to discuss some of the results they collected but that were not included as graphs on the paper. They first tested the activity in models for acute pain with the hot plate test and the tail flick assay, where ambroxol and gabapentin were only weakly effective at doses of 1000 mg per kg and 100 mg per kg respectively. In the tail flick assay and the hot plate assay, ambroxol increased the withdrawal latency. Gabapentin showed weaker effects in the tail flick assay but was slightly more efficacious in the hot plate test. Now, figure 2 shows the analgesic effects of ambroxol in comparison to gabapentin. Panels A and B correspond to the formalin PAW model as a simple model for chronic pain. On panel A, flinching was suppressed almost completely at the highest dose of ambroxol. On B, we see that gabapentin also suppressed the pain behavior, but to a lesser extent. Panel C and D show the effect of both compounds on mechanical allodynia in a model of partial nerve ligation. With ambroxol, there was a negative recording at the highest dose, indicating that in some animals the operated paw was less sensitive than the contralateral paw. On panel D, we see that there were no negative values, but there were still significant changes in comparison to the vehicle. These first experiments indicate that ambroxol has analgesic properties. Thus, the highest doses, which are 1000 and 100 mg per kg for ambroxol and gabapentin respectively, were used in future experiments for comparing the drugs' effects. Next, the compounds were tested in the CCI model for neuropathic pain. Ambroxol effectively suppressed hyperalgesia induced by thermal or mechanical stimuli, as well as cold allodynia. This is shown on figures 3A, B, and C. The effects of gabapentin were less pronounced on the reduction of thermal hyperalgesia and cold allodynia, as you can see on panels A and B, and in contrast to ambroxol, there was no significant reduction of mechanical hyperalgesia, shown in panel C. Figure 3D shows the effects of both compounds in a model for monoarthritis pain, induced by a unilateral injection of complete Freud's adjuvant. We can see that a single dose of ambroxol and gabapentin caused similar reduction in mechanical allodynia. After all the data dump, what we need to remember is that the pharmacokinetic properties of ambroxol were studied in rats and compared to humans. The animal data of this study demonstrates that ambroxol suppressed pain-related behavior at plasma levels in a variety of models for chronic, neuropathic, and inflammatory pain, with similar or enhanced effectiveness than gabapentin. Nowadays, there are other compounds shown to be effective in several neuropathic pain animal studies. Some of them can reduce pain symptoms up to 50% at doses around 30 mg per kg. However, they can also induce nausea, vomiting, tremors, or headaches. Thus, in contrast to ambroxol, these compounds probably cannot be dosed high enough in the clinics to achieve the analgesic effects observed in the laboratory animals. Even though ambroxol has been used for so long, no analgesic effects on neuropathic pain have been observed in the clinic. Several explanations can be given. First, it is very unlikely that in clinical trials, patients with severe pain conditions were included. Therefore, the analgesic effects were unobservable. Second, the dose-response relationship of ambroxol's analgesic effects is rather steep. In consequence, only a high dose should have the postulated effects on severe pain states, and the only available preparation allowing for such dosing is the 1 gram solution for infusion. Also, some patients have to be treated in intensive care units, where they receive multiple medications, including painkillers. Thus, the analgesic effect of ambroxol was overshadowed. Third, perhaps, today's state-of-the-art animal models of chronic, neuropathic, and inflammatory pain simply are not predictive for related pain states in man, and therefore ambroxol cannot show analgesic properties in the clinics. In conclusion, ambroxol has similar analgesic effects to those of gabapentin in animals, but only a clinical trial could answer the question whether ambroxol might be effective for the treatment of neuropathic pain in humans. Thanks for watching!